Hello, in this video we're going to go through the first half of the notes of 2.4. So 2.4 is about inequalities of absolute value functions and quadratic functions. So in this video we'll do the absolute value functions, and then I'll make another video that will go through the quadratic functions. So let's actually take a step back and look at some linear functions and talk about some inequalities. So here we have two lines. F of x is 3x plus 2. Let me get my pen working right here. And then we have g of x equals 4, so that's just a horizontal line. So this first problem asks us to solve f of x equals g of x. So we're going to set those two equal to each other. 3x plus 2 equals 4. Okay, so we'll subtract 2 from both sides. We'll have 3x equals 2. Then we'll divide both sides by 3, and we'll have x is equal to 2/3. Now, if we want to solve f of x is less than g of x, we would actually do the exact same thing, just with the less than symbol instead of an equal. So we're going to get, so this is just one point. It would be x equals 2/3. Here we'd get x is less than 2/3. So that's an interval. That's going to be the interval, everything less than 2/3. So that would be from negative infinity all the way up to 2/3. And then if we solved these two and we had a greater than, we would get the set x is greater than 2/3. So that would be the interval from 2/3 up to infinity. Now let's take a look and see what this means on the graph. Now if we graph 3x plus 2, that's the line with an x-intercept at 2. Sorry, my pen's being funny. At 2, and then we would go up 3 and over 1 to get another point. And we can go down 3 into the left one. So we get this line right here. And then our other line, g of x, was just a horizontal line at 4. So what's happening is the point where they're equal is the x-coordinate where they intersect, that x-coordinate right there. Okay, so that's the point where they're equal. Then when we're talking about where is f of x less than g of x, well, this line right here is f of x. So anywhere where the line, the non-horizontal line, f of x, is below, is under g of x, so all the way from negative infinity up to this point where they cross, this would be the area. That's where f of x is less than g of x. Then at that point where they intersect, they're equal. And then after that, the line, our non-horizontal line, f of x, is above our horizontal line. It's bigger than it. So there, all of those x values, that's where f of x is greater than g of x. Okay, so we have this all summarized in our notes. And this doesn't have to be for lines. It can be for any function. So if f of x and g of x are functions, then the solutions to where they're equal are the x-coordinates where they intersect. Okay, so just the x values where they intersect. Then if we want to know where is f of x less than g of x, that's going to be the x-coordinates where the graph of f of x is below the graph of g of x. And if we want to know where f of x is greater than g of x, that's going to be the x-coordinates where the graph of f of x is above the graph of g of x. So we can look at a graph, and g of x is this one that's kind of, I don't know, like a pyramid with its top chopped off or something. And f of x is our something like absolute value function, okay, the v. So it says solve f of x equals g of x. So that means we want to know the x-coordinates where they intersect. So right there, so that's x equals, we'll have to estimate, but maybe negative 2.5. And then here at x equals 3. Okay, then we want to know where's f of x less than g of x. So where is the graph of this v under the graph of this other shape? So we see from here, from negative 2.5 all the way to 3, it's below. So we're going to write the interval from negative 2.5 to 3. So remember, this is an interval, not a point. And then where we want to know where f of x is greater than or equal to, so equal to just means we'll use brackets, than g of x, well that's let's assume these go off in both directions. Okay, that would be from negative infinity up to negative 2.5. And we use the brackets because it's a greater than or equal to. It has that line under it. And then starting at 3, it's above again. So from 3 to infinity. Okay, so that's how we can do it looking at the graph. Okay, so now we're actually going to get into solving inequalities with absolute values. And these are a bunch of rules, but we'll see, we can kind of figure it out as we go along. Now the first thing to notice is that 1 and 2, this looks like a long list, but a lot of them are very, very close to each other. So let's look at 1 and 2 together. The only thing you'll notice is here we have x is less than c, and here's it's a less than or equal to. So here we're just adding an equal to. So here we're saying if c is greater than 0, so we have a positive c, a positive thing on our right-hand side, on the side that's not the absolute value side, then if we want to solve the inequality x is less, the absolute value of x is less than c, or less than or equal to, we're always going to set up two inequalities. So here you'll see that we, one way to think about it is we flip the sign so it's pointing greater than at the x, and we make the c negative, and one we rewrite it without the absolute value. Okay. Now, if c is less than 0, if c is negative, and we want to know where is the absolute value less than a negative number, or less or equal to, well, that can never happen. An absolute value can never be less than a negative number. So there we get no solution. Now 4 and 5 are very similar again. Here we say we have a positive c value, and we have the equation where it's x is greater, the absolute value of x is greater than that c. So again, we're going to set up two things, and you can kind of think of the same thing. You're going to drop the absolute value, flip the sign to make it less than, and make the c negative. And then you'll rewrite it once more without the absolute value. Okay, and then the very last one, if we want to know where x is greater than a negative number, the absolute value, well, it's always greater than a negative number, so there we get all real numbers from negative infinity to infinity. Okay, so we'll go through a few problems. Okay, so here we have the absolute value of 2x plus 3 is less than or equal to 11. So this is one of those, I think this was number 2. So we're going to set up 2. We're going to set up negative 11 is less than or equal to 2x plus 3, and we want 2x plus 3 to be less than or equal to 11. So we would subtract 3 from both sides here. So we'd have negative 14 is less than or equal to 2x. We divide both sides by 2. And we see that x is greater than or equal to negative 7. Okay. So then over here we'll subtract 3 from both sides. We get 2x is less than or equal to 8. So we get x is less than or equal to 4. So we want x to be greater than negative 7 and, remember we saw the word and up there, less than 4. So that's going to be everything between negative 7 and positive 4. So that would be our solution. Okay, now you'll notice for all of our rules we first had to get our absolute value on a side by itself. So that's going to be our first step here, is to get the absolute value by itself. So we're going to subtract 5 from both sides. So we'll have negative 6 absolute value of 3x plus 2 is greater than negative 12. Now we're going to divide both sides by negative 6, and here's where you need to remember that if you're multiplying or dividing by a negative number, you switch the sign. So here we had a greater than, we're going to change it to a less than. So we have absolute value of 3x plus 2 is less than positive 2. So here's where we're going to get, again, two different, this is now very similar to what we had. And we're going to have negative 2 is less than 3x plus 2, and 3x plus 2 is less than 2. So here we'll subtract 2 from both sides. We'd have negative 4 is less than 3x. We would divide both sides by 3, and we'd have negative 4/3 is less than x. Over here we'd subtract 2 from both sides, so we'd have 3x is less than 0. divide both sides by 3, and we get x is less than 0. So we want x to be bigger than negative 4/3, but less than 0. So we're going to go negative 4/3 up to 0. And here we use the parentheses because these are just less than signs. Okay, let's do one more. So here we actually have two inequalities. We want the absolute value of x minus 3 to be between 4 and 7. So first we're going to look at 4 is less than absolute value of x minus 3. And then we'll look at separately the absolute value of x minus 3 is less than or equal to 7. Okay, so first we'll solve this one, which is 4 is less than the absolute value of x minus 3. Now we haven't done any just like this yet, and we're going to set up two equations. So we're going to say negative 4 is greater than x minus 3, and you'll notice it was the word or when we had something like this, or x minus 3 is greater than 4. So if we solve both of these, we add 3 to both sides, and we have negative 1 is greater than x. Another way of saying that is x is less than negative 1. Or here we would have x is greater than 7. Now this part, just for this part of the problem, x is less than negative 1. That would be negative infinity up to negative 1. And then the or means we're also going to do everything bigger than 7. So 7 to infinity. Now we solve this other part. We also need it to be true. And so we would set up negative 7 is less than or equal to x minus 3. And x minus 3 is less than or equal to 7. So when we add 3 to both sides, we get negative 4 is less than or equal to x, and x is less than or equal to 10. So this is what we've seen before, and this is where we would have the interval from negative 4 to 10. Now, since x is between these, we need both of these to be true. We need to know where is this overlapping, and here I think it's helpful to draw a number line to see what's going on. So here we want everything less than negative 1. So we can think of it like that, and then bigger than 7. So we have those two lines on the number line. And here we want everything between negative 4 and 10. So we would want, these are closed dots, that line there. Now our answer is going to be everywhere where they overlap. So they overlap here between negative 4 and negative 1. So I'm going to write our answer up here. So we would go from negative 4 up to negative 1. The negative 4 is a bracket because it's closed, and then negative 1 is open. And then also from 7 to 10. Okay, so this was everything on the absolute value inequalities, and then I'll make another video that will go over the quadratic inequalities.